Mark Chen, research
Hi.
scientist at OpenAI. Welcome to the Data Exchange podcast.
Hey, how are you doing?
So we are here to talk about this amazing new project called DALL-E 2, in fact.
Mhm.
So I think it's fair to say most people have heard of this, but just in case, Mark, very briefly, what is DALL-E?
Yeah, so DALL-E is a large neural network. So it is a model which can take input, which is natural language. Basically, you can type in a sentence of text, and the output is an image that the model creates. So this is an existing image on the web, but it's one that's synthesized by the model to match the input that you've written.
So we'll talk about obviously how DALL-E works, but very quickly, just as a high-level overview. So who were your target personas users for DALL-E?
I see. So I would say throughout the development, I think we never had like, oh, this is like a user base that we want to build a product for. I think we're all kind of researchers by trade. I think generative modeling, I think in itself is just a very exciting pursuit. And I would say maybe even in the earliest days, I think in some sense we were building the model for ourselves because we're not very artistic. And just being able to create the images that we want was very exciting.
So since it's been released, the second version,
Mhm.
so for you personally, so what have been some of the more amazing use cases?
Yeah. So I think it's been surprising how much the artistic community has latched on to the model. And we've seen, like artists are just very creative when they're presented with these kind of tools. So some people, they've like designed, they've rendered wacky dresses and actually like designed them in person. I think there was a chef or something who used this as a way to find inspirational ways of plating the dishes. So they would kind of go into DALL-E and kind of write out, a bunch of ingredients and kind of get a way to plate the dishes. So yeah, it's just like so many different types of use cases. I think some people have created children's books and yeah.
Wow, really?
Yeah.
That is amazing.
Yeah.
So DALL-E obviously did not come out of nowhere, right? So it's built on prior work. But
Yes.
before we go into how you guys built DALL-E, so a system like DALL-E is unlike many machine learning models that people build, in the sense that, if you have a machine learning model, usually you know what the right answer here
Yeah.
is, right?
Yeah.
So here with DALL-E, you have to kind of come up with metrics that gauge whether or not the model is doing well.
Yeah.
And I guess, Mark, one thing that reminds me of, and it's not quite, DALL-E is actually harder in this sense,
Mhm.
is text summarization, right? So text summarization,
Mhm.
what's a good summary?
Yeah.
It's kind of subjective, right?
Yeah.
So
Exactly.
what is so how do you evaluate a model like DALL-E? How do you know when you guys are headed in the right direction?
Yeah, that's actually a fantastic question. I think the inherent trouble, like you said, is everyone has a different notion of what a good image is. I think there's some people who are like, oh, it must be correct, in the sense that like if I ask for an object on top of another object, it has to be that. Some people they care, oh, is it artistic? Does it, does it make me feel a certain way? So like everyone's kind of judging images in a different way. For us, yeah, I think we tried to lean on several different types of evaluations for this reason. One, of course, I think the gold standard is just having humans evaluate the images. So this is usually,
more than one human.
Oh yeah, more than one. So generally like kind of contractors that we hire, and they're presented with like captions and images, and they have to say, oh, like does this caption match the image well, and how well does it match the image? And typically like we'll set these up as comparisons with previous models. So that's one type of evaluation. There's also automated evaluation. So basically, maybe we can go into this later, but they're kind of clip models, which can automatically score for you how well a caption can match an image. And we can kind of use these other neural networks to evaluate how well we're doing.
So the field in machine learning research where DALL-E is situated,
Mhm.
there is no benchmark, right? So there's no ImageNet.
Yeah. I think, yeah, we've had to kind of create a couple, and of course there's some that are just starting to become popular. Yeah.
All right. So then now let's delve into a little bit as to how DALL-E works. So
Yeah.
first of all, what's the so-called training data?
Yeah. So we have several 100 million paired images and captions from the internet. And I would say a large portion of this is just data that we've purchased and licensed. Another big portion of this is just publicly available images and captions that you find online. So you really need kind of like on the order of hundreds of millions of these images and captions to get the system.
And so these paired images and captions, are they only in English?
Yeah, so we actually try to do some filtering to make sure, the captions are in English. I think we have better quality metrics for English captions. And in the future, I think it would be great to extend this to other languages. Of course, there's some bleed in from other languages, like even in English text, you'll often find words from other languages. But yeah, I think for this iteration, we tried to focus on English.
So what is what's the data quality checks?
Yeah.
Because now we're talking hundreds of millions, like you said.
Yes. Yeah. That's a really good point. So I think generally we started from a much larger pool even than hundreds of millions of images. And of course, it's impossible for a human to go and be like, oh, this one's good quality, this one's not. You just can't do it at that scale. So we actually have some models that kind of, we first kind of train a model on generally high quality paired images and captions, and kind of use that as a filter to see, for new data that we haven't seen before, like are the images and captions actually related?
So do you have like tools like, so I'm actually friends with a couple of people who just built a tool for image data. And basically what they do is they can actually, so it's written in C++, it's super fast. They can go through millions of images quickly. They start with a vector. Then they can find, if there's duplicates, if there's mislabeled data. So do you have like automation tools like this?
Yeah, exactly. Yeah. So we have a very similar tool kind of in-house to what you described. Just like very easy to go and see, like, is this image kind of a very popular image and duplicated many times? And like you might worry about this for like memes or something like this. So we do have that tooling in place, but it's kind of in-house.
So machine learning is a community. So projects build on top of each other. So in the case of DALL-E 2, obviously there's DALL-E 1.
Yeah.
You mentioned something called CLIP. So take us through kind of the evolution of from CLIP to DALL-E 2.
Yeah, that's a really good question as well. So I can also kind of give some context from DALL-E 1 as well. And yeah, I think when we developed DALL-E 1, I think this was just when this kind of you can use a transformer model to model kind of any type of data. That paradigm was really starting to kick in. And I think this was one of the really compelling demonstrations that you could put like image data and text data together. And like the transformer will just learn how to how to make sense of both of these two different types of representations. And in this way, we were able in DALL-E 1 to generate images kind of almost in a blockwise fashion. So just like starting at the top left and then generating small blocks until we generated the whole image.
But same kind of interface where I start out with a language description, and exactly. Then block by block you would build.
Right, exactly. So DALL-E 1 worked like this. I think, just like kind of seeing this block by block interface, it definitely gives you a sense that this isn't the optimal way to kind of generate images, right? Like this is very different from how humans generate images. We definitely don't
that's very similar to at least in the early days of deep learning in computer vision, right? So they do kind of these little blocks, right? So
Yeah, I think it is like it has been explored in the past, but it does feel wrong in a certain sense. Like humans definitely don't generate images by kind of like acting like a printer. So yeah, I think more recently there's been work done on diffusion models. And I think this came out of Google Brain and also kind of some work at Stanford. And it's kind of a new architecture for synthesizing images. And the way that this works is you start with a completely noisy image. So this is something where you wouldn't be able to tell like there's anything in the image. And over many, many steps, you gradually remove the noise in the image.
So you have like an actual image that you know.
Yes.
So
Yeah. During training, you have an actual image, but then you noise it to a certain extent, and then you train the model to remove this noise. And you can kind of do this in little steps, and eventually, you can start with a fully noisy image and then create.
It's actually the way you describe it. This is how sometimes you visualize something, right?
Yeah.
Maybe you're from afar, or maybe it's fogged, and then it becomes clearer. Right?
Yeah, that's a good analogy because it's like it definitely starts out looking fairly blurry. And it's like, after like a couple steps, you might be able to be like, oh, I can kind of see like, oh, there could be these objects in the image, but then you kind of crystallize it and make the details clear over more steps.
So let's assign some years here. So DALL-E was what year, and then what year was this diffusion model?
Yeah, it was actually fairly fast in succession. So I may be wrong, but I think the original DALL-E was maybe like 2019 or so. And then the diffusion work, I would say either like kind of like late 2020 or early 2021.
So in both of these cases, Mark, the same kind of data situation, you need hundreds of millions?
For DALL-E, for diffusion, I think the early work, you could use much smaller data sets, but I think we had some work here at OpenAI, also kind of, I think 2020 to 2021, where we were pushing these diffusion models to the state of the art on ImageNet. And I think gradually like people were figuring out how to make it work on larger data sets. Yeah.
And so you mentioned CLIP.
Yeah.
Significant.
Yeah.
So and assign a year to CLIP as well.
Yeah. So that was also, I would say roughly a year and a half ago. So what CLIP is, just very quickly, is there's two neural networks that act as encoders. So what this means is if you have a caption for an image, let's say it's a bunch of text, you turn it into a vector, just a list of numbers. And you do the same for images. So what you want is when you have a caption and its corresponding image, you want these vectors to be very similar. And when these two kind of image and the text are unrelated, you want these vectors to be very dissimilar, so as orthogonal as you can.
In other words, the way you vectorize should result in this kind of similarity or dissimilarity.
Yeah. So you explicitly train the model on this objective. Yeah, to like make the caption and text features very similar, and captions and unrelated images dissimilar. This was some work that came out, like I said, roughly a year.
So Mark, in that sense, then let's say I have two images, right? So they have captions.
Yep.
The captions are similar in the NLP sense. So then can't I use those NLP embeddings for the images?
I see. Yeah. So I think there's a question of, when you're training CLIP, can you start with some like pre-trained language models?
Yeah.
And these language models might already have really good senses of kind of what is similar text. I actually don't remember off the top of my head like how much the pre-training on the language side helps with CLIP. But yeah, it's conceivable to me that it would make training a lot more efficient.
And so then is CLIP essentially as you described them? Those two encoders is CLIP.
Yes. Yeah, those two encoders is CLIP. Yeah. So
and what were the early applications of CLIP? Divorce DALL-E.
Yeah, exactly. So CLIP in itself, basically you learn this vector space where, images are treated as vectors here, and text is treated as vectors. And so, you have this shared vector space for two different modalities. And one thing you could do is you could do classification, for instance, right? You could take like an image, you encode it into a vector, and then you try to encode all the classes also into vectors and use it for classification. And you might wonder, well, we already have really good classifiers, right? Like why use CLIP for this? So it turns out that CLIP is actually an extremely robust classifier. So there are like a lot of benchmarks where, you take ImageNet and you actually change it in some way. Like you create drawings of all the classes instead, or you like create like slightly adversarial images for all of the classes. And it turns out that CLIP works way better than off-the-shelf models on, this large distribution of images.
So CLIP, original application of CLIP was around classification?
Yeah, I would say kind of like more discriminative tasks. Yeah, just like classification, I think like visual question answering. Yes, so some of these kind of, I guess, classical computer vision benchmarks. Yeah.
So then now we have some of these building blocks. So take us through the origin story of DALL-E 2. So what was the eureka moment for that? Or maybe there was no eureka moment. Maybe it was just a steady progress, right? So
So I think just starting with CLIP as a base, I think one of the big motivations for us was like, can we go backwards? Can we kind of turn the encoder the other way? So we have an image feature vector, and can we turn that back into an image? And for us, it made a lot of sense to build this because one, it gives us a window into, we can figure out how the model is visualizing certain concepts, right? Like you just take a vector and you can generate a lot of different renditions for what the model sees. And it actually enables you so many capabilities. Like if you want to take an image and get a very similar image, you can get its image features and then kind of like go back into image space. So you've like kind of built this bridge. You can like take an image, you can encode it, you can kind of perturb it using some text because you have the text feature vector. So it just felt like a very rich environment with a bunch of different capabilities. And that was really the motivation. It's like we can build this generative model that takes text, creates images, but it also comes with a bunch of capabilities for free.
So this is a space where compute, you can get really into really serious computation. So when you have an idea like this, Mark, how do you kind of test it out at a rather small scale before you decide let's let it rip?
Yeah, that's a great question. So I think like at an early stage, there has to be somewhat of a leap of faith. Like you have to kind of believe that, at scale, you will get kind of different behaviors. Like it is the unfortunate fact for a lot of these large models that, when you train it at small scale, like it's just not super good. Like, you won't be able to generate, different objects in the same scene in a reasonable way. But the thing is that like you can kind of build very good kind of quantitative evals and automatic evals. And even though maybe like visually at small scale, like these images still don't look super great, but you can still track kind of improvements in metrics. And we do really believe in this, like start small, get some signs of life. Like it should still work for, very simple prompts, for instance, right? Like if you're just ask for a dog or a cat, and then, like you want to start simple, and then you expand the scope of the complexity of the prompts kind of as you scale up gradually. So you want to scale up, see that your metrics are improving predictably, and also to kind of like see where the boundary of the model is. Like how complex can you make the prompt before it breaks down?
So how would you describe DALL-E 2 now? So is it as you described, it involves all these encoders and CLIP and
Yeah. So it basically, it takes this same text encoder from CLIP. So that's just fixed. We don't touch it. So the way you generate an image, you take this text, you pass it through the encoder, just the way that CLIP does, and you get this kind of list of numbers, this text feature. And then what we do is we convert it into an image feature. And then we take this image feature, just another list of numbers, and then we use the diffusion models, which I talked about earlier, to turn it back into an image. So it is kind of this multi-stage process, and it reuses a lot of the machinery from CLIP.
So is there a place in here for something almost like equivalent to GANs, where you would have like a competition between different models?
Yeah, that's actually a really good question. So there's no reason you really need to make like you don't have to choose a diffusion model, let's say, to like render the image from your latents. And actually, again, sounds like a very good choice for this as well. If you have these kind of clip vectors to condition your GAN on, it's very plausible that you could train a GAN to do this as well. I think the reason we chose diffusion models is I think lately in a lot of kind of practical image generation settings, they've been outperforming GANs. But again, like GANs do have certain kind of aspects which make them very appealing. They're like very, very fast, in generation. And so it comes with different trade-offs.
So these models are almost like under the rubric of do not try this at home because of the amount of compute involved. Maybe you can give us a hint in terms of what kind of distributed computing tools you need in order to pull off something like this. Like what scale are we talking about?
Yeah. I mean, in general at OpenAI, we're training on models on a large number of GPUs, right? And kind of at that scale.
Did you build your own tools for doing all of this training, or do you use things like Ray or?
Oh yeah, so definitely Ray is an amazing tool, and I think we have parts of their system built into certain components that we built on our own infrastructure. So I don't know too much about the specifics of how Ray is integrated, but yeah, I think we think highly of
and full disclosure, I'm an advisor to Anyscale, the company.
Oh, cool. I know Robert very well. So we go way back.
And, so that's great. So then so you use some open source components, but you build your own tools too internally. But when you talk to people in this field, right? So in the past, you may say, okay, so one of the reasons why maybe academics may have a hard time competing is they don't have enough data, they don't have enough compute. But increasingly, it's really they don't have enough systems engineers to really execute and pull this off, right? So let's say I'm an academic somewhere, I have data, I have compute, but I may not have all of the engineers that I need in order to execute, right?
Yeah. I mean, it's a very real problem, and I would say there's still, in my mind, there's a lot of room in academia for really impactful work here as well. Like a lot of the ideas, like the score matching kind of based interpretation of diffusion models that originated in academia, and a lot of these kind of improvements on the core methods are still coming from academia. So I don't think that that's going to change anytime soon. And I also think, in academia, there are starting to be large scale efforts where, like universities are coming together and they're saying, okay, we're going to pull resources and, like actually have a dedicated team of kind of engineers to like build a model which we can use as a starting point for a lot of our experiments. So
or a team of engineers that can take our ideas and scale them.
Yes.
At massive scale, really.
Yeah. And I think I don't know the names off the top of my head, but my impression is there are already some of these, like universities coming together and pooling resources and getting these efforts started.
So would you classify DALL-E and models like DALL-E as multimodal?
Yeah, I would say, I guess it's like a kind of a very loosely defined term these days. I think at OpenAI, at least, we interpret it as, like if you're combining two different kind of sensory inputs. So here we have, text and images together. And that kind of just by default, we call that a multimodal model.
So I know that OpenAI really places a lot of emphasis on responsible AI and ethics and things like that. So how does that come into place with something like DALL-E? Because the reason I asked Mark is in the large language model space, there's an effort around detoxification,
Yes.
but I guess it's a tough problem. It's a hard problem in the
Yeah,
sense of you might be able to do it, but then at the cost of performance and
Yeah.
how good the model is. So is there the equivalent here?
Yeah. There is very much so. And yeah, I want to say it's a problem that we take very seriously. And I think like we wanted to take the time to address these things before launching. And so like
I mean, you have a whole team of people just focused on this issues.
Yeah, exactly. So yeah, I mean, I can talk about like if you'd like, I can talk about some of the mitigations that we put into place. But we really care that we're not generating like violent content, sexual content. Like I think a lot of the norms that it's a very new field, right? For
so
like,
are these are these basically just you take the model and then you have a rule-based system at the end?
No, I think we certainly do have those in place as well. I think like you can kind of think of it as like we have many layers of mitigations, but we think like rule-based is not enough. Like you have to start from even the training data, like remove the violent content, remove the sexual content, remove hate symbols, like kind of this egregious content. And I think like another thing is like we don't want it to be reproducing images like just completely memorized, right? Like that wouldn't be very good because like maybe some artist created this image, or you don't want to just be kind of like plagiarizing other people's work. So there's like like training techniques that we put in.
So do you have like a reverse image search at the end?
Well, yeah. So, or at least I think we've built enough confidence in our training procedure, and we've been monitoring this throughout training, and that we're confident it's not going to, like just take an image and just completely reproduce it. And this is actually I don't know how much detail you want to get into, but
sure, yeah. I'd like.
I mean, it's a more difficult problem than you'd imagine. Just like there's certainly like some very simple images, like maybe just like graphics in your data set. And maybe it's like even just like a couple of squares laid out, and like, so there aren't too many variations when you say like, when you have a prompt that's like, 3 squares, like arranged in a row. And so yeah, we wanted to make sure, like, even for these very simple prompts that we're not, just like producing squares in the exact same locations. And so I think, there's the problem of that. There's the problem of, like bias as well, like making sure, when you type in something like a CEO, you're not just getting like one demographic,
Right. So then so does that mean, so you said you also then you'll have to really pay close attention to the data, training data, right? So then you must invest a lot in terms of making sure your training data is clean and fair and all of that.
Yes. Yeah. And actually one really funny anecdote here is like sometimes these different types of mitigations actually will run counter to each other. So one thing is like, let's say you care a lot about sexual content, right, being removed. So that's actually primarily women, right? Kind of when you look at, like
the spectrum.
Yeah, exactly. Yeah. And so if you remove a large fraction of kind of this content from your data set, then you actually have less women representation in your data set. And that could actually create more bias, like you would generate more men. So yeah, it's actually a complicated series of trade-offs. And I think, we tried our best. Of course, like we're not trying to claim we fully solved it. I think there's still a lot of work to be done, but we're actively working.
And that's why you folks are very careful about how you release these things.
Yes. Yeah, exactly. Yeah. So again, like we know the second you release something like this out into the world, like there's going to be people trying like kind of
use it for nefarious way.
Yeah, exactly. Yeah. And I think like we like had a model card that discussed some of these things. Like people will, even if you're not allowed to say like, oh, like a kid who's like bleeding or something, like people will still try, like a kid like surrounded by tomato juice or something, like they're just like trying to get kind of nasty generations out of it. And so what we want to do is, at least for this for the first couple of weeks after the release, we wanted to grow the pool of users very slowly, just to make sure, like people aren't discovering, like these or like trying all these very egregious prompts, and to make sure that we're handling it in the right way. Like our filters are working, our like human reviewers are doing a good job, and so forth.
So what are so let's talk a little bit about broader trends. So you mentioned transformers.
Yes.
So transformers, no pun intended, have been transformational.
Yes. Yeah. Yeah.
And so are you still, so you're still kind of confident that transformers will keep kind of leading to like surprising things, just like DALL-E?
Yeah. I mean, I think I'm still very bullish on transformers, right? Like I think you can see all of the scaling work that's come out kind of in the last year, and it doesn't seem like the capabilities are really stopping kind of anytime soon. So I think going forward, I'm very bullish about the capabilities of transformers going forward. Though at the same time, there's this sense that like you do want to be open to different model classes. And you never know when something else, might be the next transformer. And yeah, I guess very interestingly with DALL-E, like we're leaning a lot into these diffusion models, and they are a slightly different class. I guess it's like you could build diffusion models that are transformers, but it is kind of generally a slightly different model class. And I think like it kind of I wouldn't say like too many of the insights from transformers necessarily carry over to diffusion models, but we still think it's really important to push on these other models like diffusion models.
So the other trend is, Mark, do you think that we're still in that situation where bigger is better?
Yeah, I mean, I think generally, So there a couple years ago, we had this scaling loss paper, and I think the main thesis there is, you can predictably kind of forecast, the performance of larger and larger models. And there's this kind of trend. And I think as of now, we haven't observed exceptions to the trend. So in that sense, like bigger is better, but of course, bigger is also a lot more expensive, and like anything you can do on the efficiency front is also going to give you gigantic wins. So, yeah.
So multimodal models in the true sense, are you seeing good signs around them? So where a model really takes inputs from multiple modalities and does something new?
Yeah. I think it's increasingly going to be a larger area of focus, and I think I'd also like to point to some work done at DeepMind recently on Flamingo, and that is kind of this kind of multimodal chat interface. And I think they had a couple of fairly compelling demonstrations where you can take images and like have a conversation to try to tease out what the model understands about the image, or like why is this image funny, for instance. And yeah, I mean, I think like the more senses that models are able to kind of understand and integrate in, it definitely feels like this could be really useful for getting our models to understand our world. And I think that's a lot of the motivation for why we build multimodal models here. Like we really we think that of course generative models, they give us a window into how our models perceive the world, and visualize the world. And I think it could be really useful for the model to have visual inputs for it to understand our world.
So the interesting thing about DALL-E to me is that unlike many other models in this space, it was clearly the end result of DALL-E is something non-technical people can really appreciate, right? So do you think that we'll see more and more such kind of applications of AI to more of the creative areas?
Yeah. That's a kind of interesting point. I think Yeah, when you even look at kind of what's been done in the past, right? Like, I would say, a lot of people consider coding, right, like a kind of creative line of work, and I think like there's definitely been a lot of work on models which can produce code, and
I use one every day. GitHub
yeah,
Copilot
okay, awesome, awesome.
based on what you guys have built.
Yeah. So I definitely think like, these like creative tools. I I think actually one of the reasons that, there's so much work and kind of interest in building these creative tools is, if we just kind of built something that, feels like, oh, this is like a very easy kind of like, I guess more like kind of like formulaic task. Like it's just like you can write out a couple instructions and this is just how you do the task. Like that doesn't feel like, oh, like you've created a model which like it is very surprising, right? It's like if it can just follow a kind of series of steps, building some kind of system that can do it just doesn't feel that exciting. And I think it's just when you move into kind of things that people consider creative, like, art or kind of generating images, writing code, if a model is able to get signs of life, then you feel like you're making progress. And I think that's why so many people are kind of interested in building models around these creative applications. Just, like you could say, oh, I built a model that can like kind of take out the trash or something. I guess like that doesn't feel like you're making that much progress in some sense.
So without revealing obviously secrets or proprietary information, so what would be the natural next step from DALL-E 2? So I like, as we started this conversation, this is an area where there's no benchmarks, right? So it's not like you can go, oh, let's lower the benchmark even more. So what would be the natural next step to pursue?
I think while the current system, it generates fairly photorealistic images, I think there's still some limitations, right? So there's limitations sometimes when it comes to variable binding. And what I mean by this is like, let's say you have like two different objects and like two different adjectives for these or attributes for these objects. Sometimes you could get these kind of mixed up. That's just something we know as a failure case. I think in terms of like it being able to like generate text well, that's also a limitation of the current model. So we think, there's like some low hanging fruit to really improve the capabilities of the model. And I think, I guess if we're kind of thinking about creative applications, right? Right now, what it does is you take some text and you get an image that you might kind of find on the internet. Like let's say like, if you had typed it into, Google image search, right? But what we like, if we want a model to be creative, maybe we want it to generate, new kinds of images that don't reflect what humans have created before. So like that's maybe one axis where we could push on. So I think there's like a lot of different ways to take the project. Like you could kind of work on the creativity aspect. You can work on the kind of patching up the low hanging fruit. I think like even like applying this kind of paradigm to other modalities, right?
What about taking text and generating video?
Yeah. I mean, it's like something a lot of people suggest, it like comes up as a natural next step. I think there is this kind of a little bit natural fear.
Or I guess 20 years from now, Mark, it might be, here's my screenplay.
Yeah, exactly.
And then produce the movie.
Yeah, exactly. Like, I mean, you definitely start to think about applications like that. And I guess like traditionally video has been a very scary space just because, like images is like, you can think of it as like a single frame of video, and video, it's just like, you have how many frames per second over so long. Yeah. So like it just, in terms of like the complexity of the problem, the input size is much larger. So, but I do think, like there's signs of life, and I'm sure like in the next couple of years, we'll be seeing some really powerful video models.
So the current version of DALL-E, and let's say DALL-E a year from now, do you think at that point, let's say a year from now you're starting to hear designers saying, hey, this thing is making me so productive at work. Just like we use GitHub Copilot, maybe they'll have like DALL-E Copilot.
No, I think our vision really is to get this into the hands of people as soon as we can. And I think we've launched labs like of course, like we want to balance that with responsible rollouts, like just like make sure, you know, we're at a good kind of equilibrium where, you know, the contractors reviewing all of these generations aren't, you know, like they have enough bandwidth. And but really, like as soon as possible, we want to get this in the hands of everyone. And yeah, I think like, yeah, thinking about it, like Copilot does seem like a pretty apt model. Like, yeah, we just want to get it.
Yeah. Because I mean, think about the game designers and how much they have to do to, you know, in a game like multiplayer game where there's so many things that they have to design.
Yeah.
So, and
Yeah,
they can
like
just be
generating-
so productive,
Yeah.
right? So,
Yeah. Or yeah, if you think about like people who want to like generate assets, you know, like every person who plays my game should have like a character that they want, you know, or they can even create maybe. And yeah, I think there's just a lot of cool applications there too.
yeah. And with that, thank you, Mark Chen. This has been awesome.
Yeah, thank you. I really enjoyed meeting you and chatting with you.